This is the next question. I want you to try and understand the question. Again, I am going to disappear for a small moment, and you can see this is a 25 mark question. So, you will get 25 marks, points, call it whatever you want. Okay, and totally if you scroll on top, we need I think how many? We need 30 points, I think, right? For the, no, I mean, sorry, it was not refreshed. Okay, we need 50 more points, and it will give us 25 points. One more question, we will have 2 stars. Okay, cool. Let's go and let us try and understand. Again, it's not about the stars. Okay, don't become like a person. You're not a film star or something that you have to be behind the stars. Just a incentive. It's just a motivation to solve. But the true purpose of this workshop is to not make you a star in HackerRank or give you stars. It is to ensure that you understand the foundations of coding, build a strong foundation of logic, and then go ahead. Okay, come down. Okay, read this please. Who is ready with the solution? How many of you have the solution? Put a yes in the chat, let me see. How many star programmers are there in the class today? Solved. Very nice. Okay. Okay. So beautiful. Okay, great. Awesome. Nice. So most of you have got it. Let me just spend 2 minutes explaining the solution to you guys. Okay. So now first question. An integer d is a divisor of integer n. If I divide n by d, remainder should be 0 boss. That's all he's saying. Correct. Perfectly divisible. That is when any number which can perfectly divide another number is qualified to be called as the divisor of that number. Okay. Given an integer, for each digit that makes up the integer, determine whether it is a divisor. Count the number of divisors occurring within the integer. Example 1, 2, 4. 1 is there, 2 is there, 4 is there. These are the integers which make up that number. Now, can 1 perfectly divide 124? Yes, so 1 is a divisor. Can 2 perfectly divide 124? Yes, 2 is also a divisor. Can 4 perfectly divide 124? Yes, so 4 is also a divisor, which means all 3 numbers divide evenly into 124, so return 3. If I take 111, obviously 1, 1, 1, all 3 are divisors, so return 3. If I give 10, come down, check whether 1 and 0 are divisors. 1 is a divisor, but 0 is not, right? So what you have to return is 1. Any confusion till this point of time? So find digits is the function. Okay, I'll just select that. Now, what I'm going to do is, let's go and implement the logic. So all it is saying is that, what should it do? It should accept n, which is the value to analyze. It should return the number of digits in n that are divisors of n. That's all. If I come down, see, you have two inputs. So 12. So 12, 1 is the divisor of 12, 2 is the divisor of 12, so 2. 1, 0, 1, 2. 1 can divide 1, 0, 1, 2. 0 cannot. 1 can, 2 can. Which means how many divisors? 3. 1, 1 and 2. So 3. That's it. I know everybody understood the question. Let's quickly go and do it. So one more question we can solve today. Okay. So now first of all guys, see, there is a very simple logic which I want you guys to think. See, I have 124. I have 124. What I want to do is, I want each individual number. So how will you remove each individual number? That is a very simple logic. Let us assume I want to remove this last digit, which is 4. Those of you who do not know how to remove a last digit from a given integer, the concept is very simple. All you have to do is divide this number by 10. If you divide this number by 10, what you are going to do is, maybe you will tell 12, which means you will get 120, in which case the remainder will be 4. As you can see, this remainder is nothing but the last digit. I hope you are able to think. So in programming, if you can divide this number, divide any number by 10 and collect its remainder, you will get the last digit of that number. Which means all you have to do in programming is 124 mod 10. This is always going to give you 4. Now next time I want 2, let us assume. So what I should do is I must not only get the last digit, I want to remove the last digit. If you want to remove the last digit, you can see it's very simple. If I divide 10 by 124 by 10, remainder is the last digit. Quotient is the digits minus the last digit, see 12. Which means if in case I do 124 divided by 10, what I am going to get is 12. 12 is nothing but minus the last digit. So to get the last digit, modulo 10. To remove the last digit, divided by 10. So in general, I can say n mod 10 will give me last digit. Whereas n divided by 10 is going to remove, so the last digit. Is this logic clear to everyone? Put a yes in the chat. I know everybody knows this already, but if in case you didn't know it, is this clear to everyone? Yes, 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 yes. Okay, awesome, good, nice. Okay, Ji. Now that you have understood this, let's go ahead and let us solve. Okay, so the question is very easy. N is 124. 124 divided by 4 divided by 2 divided by 1. Each thing will perfectly divide it. So I'm putting ticks, right? So obviously all the digits can perfectly divide the number, which means what you must return is 3. Any confusion? That is the count of divisors. If there were 2, 2. How are we going to do this? Very easy. Like this, I'm going to have n, which is my number. I'm going to have t. Why I will have this t, and initially I will copy the value of n into t is because this, if from t, I am always going to keep removing the last digit. So first time I will remove 4, then it will become 12, then I will remove 2, it will become 1, like that. So I don't want to modify n, so I will copy it into t. From t I will keep removing the last digit. And of course, I want the count, total count of the divisors for that count. And every time I remove the last digit, I want to store it somewhere. So I'll have a variable called as LD, short for last digit. So how are we going to do this? It's quite simple. First thing I will do is extract the last digit. If I extract the last digit, how will you do it? Modulo 10. If you do modulo 10, you will get the last digit. In this case, 124 mod 10 is nothing but 4. 4 becomes my last digit. I will just store it within LD like this. Then what I will do is I must check if in case what I want to now do is I want to see whether this last digit is a perfect divisor or is a divisor. So how will you do that? Just take n modulo LD you do, which means divide n by the last digit and see if remainder is 0. If remainder is 0, it's a divisor. That's it. If in case this condition is true, then if I do this, yes, it will be true. 124 divided by last digit is 4. So obviously if it is true, increment the value of count. So I'm just telling count plus plus, one value, count will increase. Then before you repeat it, I want the last digit to be removed from t. So how will I do it? T mod 10 will give me last digit. T divided by 10 will remove the last digit. Remove the last digit, store it back in t. So 124 divided by 10 is 12. 12 store it in t. T is going to have 12, which is equivalent to removing the last digit. I hope I'm clear. This process has to now again repeat. Again, if I repeat, then what I'm going to do is t modulo 10, which is nothing but I'll get 2 last digit. Store that in LD. So LD is going to become 2. So last digit is 2. Check if n can be divided by the last digit. So can 124 be divided by 2? Certainly it can be. So condition is true. If it is true, increment the value of count. Count becomes 2. Then remove the last digit from t. So divided by 10, automatically you will remove the last digit, which is what I am also showing. T 12 divided by 10 is nothing but 1. So see, automatically that will become the value. Then again repeat this. So if I repeat this, get the last digit. So 1 divided by 10, remainder will be 1, right? So, and that is what will be my last digit. Check if it is dividing n value. Yes, it can divide n value. So increment the value of count. Count becomes 3, and then once count becomes 3, remove the last digit. So if I divide 1 divided by 10, it is obviously going to become 0, and 0 is what I will store in t, and once t becomes 0, you must stop. I hope you are able to think. So in a way, you got your condition. This has to keep repeating as long as t is not equal to 0. The moment it becomes 0, stop. Hope you are able to think. How will we write it? That we will see. Anyways, I hope this part is clear to everyone, and that is what I am also writing. So t greater than 0 or not equal to 0, both ways will work. As long as effect, if you want, you can use a loop called as while loop, because we don't know how many times this has to execute, but we know that it must keep executing as long as a certain condition is satisfied or not satisfied. You can write it in either ways. Either you can check for true or you can check for false. Here I am checking for true. I am saying as long as t value is greater than 0. While, always start reading it as long as. As long as t value is greater than 0, find the last digit, see if the last digit is a divisor. If it is a divisor, increase, and then remove the last digit from t. Again check if t is greater than 0. As long as it is greater than 0, repeat. The moment t becomes 0, condition becomes false, you will stop. Let's go quickly write the code. So now what I am going to do here is I will go and I am going to delete whatever is there inside this main method. I will go there and I will tell static, and what we will be returning is after all a count, so it is an integer. Name of the function whatever we copied, find digits, what it must accept is just this n value, so int n. I'll come inside. Beautiful. Now what we have to basically do is come inside that, and here I am going to now just start writing the logic. So the logic is quite simple. I'll just go here and same logic I will write. N we already have, we need count t ld. So I'll first tell int t, and whatever is the value of n, I will assign it to t. Initially whatever is the value of n, I'll assign it to t. Okay, next. Next what I'm going to do is I need count and ld. So int count equal to 0. Next I will tell int ld equal to 0. Good. Now I will come down. Now there I have to write this while loop. So I will tell as long as while this condition is satisfied, which is t value should be greater than 0. I will come inside this and all I am going to do is this logic. So first extract the last digit. So ld is equal to t mod 10. Semicolon. Next what I am going to do is same thing. I will check if in case that last digit that I extracted is a divisor of n. So if in case n mod ld, check if the remainder is equal to 0. If that is the case, increase the value of count. So count plus. Great. Next I will come below and then remove the last digit from t. So t is equal to t divided by 10. That's pretty much it. Once I come out of this while loop, then count value will have become whatever, how many ever divisors I have. So that is what I should return. So I'll tell return count. Now watch, let's execute. So I'll come to main and just I'll tell int n equal to 124, and I'll call that last digit thing. Find digits, okay, and I'll pass n. See, now the thing is, find digits will return you count. You can either collect it in a variable, then print it, or anyways it will return whatever it returns directly. You can print it. How, sir? Put it within system.out.println. See, I'll tell sys out, same line, and yeah, I'll just put it inside. So that's all. Call find digits, whatever it returns, print it. That's it. Possible. Okay. Let's go execute. So now, if in case I go back, I compile it, no issues, I will execute it, 3. Perfect, we got the answer. Will it work? Let's go to HackerRank and check, because HackerRank will give me all kinds of inputs. And always remember, the kind of code you write must be able to give the right result for all values of n. Let's see whether we have thought about all conditions. I'll copy this and I will just go paste it. Paste it. Okay, I'll click on run code. If I click on run code, runtime error. So it is basically saying there was an arithmetic exception, it seems. First of all, I want to see what is the sample test case he passed. Let us go check that out. Maybe if you scroll down, see, this is the test case which failed. 1 0 1 2. This failed, it seems. Oh, copy that. Let's go paste it in our code. If I go and change it to n, I'll make it as that value. Now, you only tell me 1 is a divisor. Is 0 a divisor? No. 0 is not a divisor. How are you able to think? 0 is not considered as a divisor because 0 divided by anything is 0. 0 multiplied by anything is 0. How are you able to think? Or 0 divided by anything is the number itself. How are you able to think? Which means our program did not consider zeros. It did not consider zeros. And think about it, scroll on top. If my last digit is 0 and I divide n by 0, if you divide something by 0, you will get infinity. Have you ever tried dividing anything by 0? You will get infinity. Now, obviously that is a mistake. A mistake which happens during the execution of a program is only called as an exception in Java. Again, in the full stack web development course here at App Academy, where we provide 100+ guaranteed placement opportunities, there in depth I have taught about exception handling and how to handle different exceptions, etc. But see, let me just execute this and show you. If I take you to that and I just compile it, and if in case I execute it, then exception. Forget about thread. Now I have to explain multi-threading to you. Java.lang.arithmetic exception. Arithmetics means what? Division, multiplication, addition. Why did this arithmetic exception happen? Division by 0. Where did it happen? It happened in the 90th line of my program. Are you able to think? Correct. Because I divided 124 by 0 and that's a mistake. So how to avoid this, sir? Very easy. I'll go back and all we will do is one simple thing we will do. Okay. Before doing all of this division, before we do this division, all we have to do is ensure that before this if block executes, we check whether the last digit is not 0. Because if it is 0, we know it's not a divisor. Why to even divide and check? So I'll just press enter after LD. And there I will put one more if condition. If in case LD, if in case LD not, see not, equal to 0. Not equal to 0. Only if this condition is true, check if it's a divisor. So I'll put brackets, and what I will do is I'll take this if and I will cut it and put it inside this. That's all. If inside an if is only called as a nested if. A for inside a for is only called as a nested for. Okay. Alright, my dear friends. So I think we have considered this. So why don't you copy this code and paste it in HackerRank. Okay. Alright. So I'll go on top. And I'll just paste it. That's it. Now I'll click. So through this, did you understand how to check whether your code will work for all types of inputs? That is why majority of the students fail in cracking the online coding tests provided by IT companies, because one, they do not have the approach. Two, they do not know that these are the things they must keep in mind. Third, they have zero practice on such tools. And TAP Academy's duty is to ensure that none of those problems will happen to you, and that is why these 6 days of workshop. I hope you're able to think. I'll click on submit. Directly we will submit itself. If I submit it, then compilation error, end of file, some mistake you have created in brackets, check that out. Okay. One bracket closing is missing. Okay, fine. I'll just run it first. Passed. Submit it. Okay, compiling 2 test cases only, everything passed. Beautiful. Because this is a rather easy problem. Congratulations. We got 25 more points and you are now 25 points away from the second star. Okay, great. Awesome. So how many of you understood this logic perfectly and how to think about certain conditions your program would have not considered? Did you understand how to think? Put a yes in the chat. Yes, beautiful, beautiful. Good, nice.